Consider a pure inductor of L Henry, okay, and it is connected to some alternating source given by E is equal to E naught sine omega t. Okay, now every inductance will have some back EMF, so the net EMF of the whole circuit we need to calculate. Right, now the back EMF was given by what? Minus L di by dt, correct, where di by dt is the change in current. So the net EMF will be nothing but E plus of minus L di by dt is equal to 0, correct. In other words, we have E is equal to L di by dt. Okay, so this will be the total instantaneous EMF. Di will be equal to E by L into dt. Right, now what was E? E naught sine omega t. Now substitute that. So we will get di is equal to E naught by L sine omega t dt. Okay, now what you do is you have to integrate. So when you are integrating, so di integration will become I. So I is equal to E naught by L integral of sine omega t dt. So if you integrate that, you will get E naught by omega L into minus cos omega t. Okay, now so let's go back to trigonometry, last year trigonometry. See, we have sine of pi by 2 minus theta will be cos theta, correct. Now here we have minus cos theta or minus cos omega t. So this we can change it as sine of omega t minus pi by 2. Okay, so you interchange the 90 and theta. So here what we are writing is E naught by omega L into sine of omega t minus pi by 2. Okay, so I will be equal to, so I is equal to E naught by omega L sine of omega t minus pi by 2. Okay, now here omega into L, it has the same unit as resistance, which is ohm. So we call that omega L as inductive reactance. Okay, so inductive reactance, which is represented by XL. So we'll get I is equal to E naught by XL, which is I naught. So I is equal to I naught sine of omega t minus pi by 2. So here E was given by E naught sine omega t and I is given by I naught sine of omega t minus pi by 2. Meaning here the EMF leads the current by pi by 2. In other words, current lags behind EMF by pi by 2. Okay, so the sinusoidal, the graphical diagram, so this is the EMF and this will be the current. Okay, so here if you can look at the graph, the current is lagging. Now we also have to represent using phase diagram. So if this is E and see this will be angle omega t and this will be I. So here clearly you can see that I value is lagging behind EMF by an angle of pi by 2.